Thanks a lot for coming. I know that it was an exhausting day for you and you received a lot of information, a lot of good theoretical talks, also some practical ones. And thanks for choosing the tools in action type of talk for the last talk of the day. And I hope that this talk for you will be something you'll take home and then on Monday or maybe even at weekends, because well, we all work on weekends, you'll try something I was talking about today. So, test containers, huh? Let's talk about it. And before talking about test containers, I should explain who am I and why I'm talking about the topic. So first of all, I'm one of the co-maintainers of the test containers project. It wasn't created by me, but I'm actively working on it nowadays. But as my daily job, I work in a company called Pivotal in Project Reactor. And you may know Pivotal for Spring Framework and a couple of other small Java projects if you're into Java. But anyways, I live in Berlin and I'm organizing Berlin Spring User Group. And every time I say it, I also add that if you're in Berlin, please go to meetup.com, check Berlin Spring User Group, and maybe there will be some event. And we usually have some really good events. For instance, Nicholas was giving a talk a couple of weeks ago or something, or maybe months ago. So we have some really good speakers there, just for meetup for free, of course. And my passion is working on developer tools and making other developers' life easier and simple, because that's the best I know, because I'm a developer. I have some struggles, I have some pains. I don't want to have any pains or struggles, so I want everyone to provide a good quality code and stuff like that. And I also want to help others to make it possible, basically. So, today we're going to talk about integration testing and tooling for the integration testing, but before talking about the topic, we need to define what is it, integration testing. And let's start with visual explanation. So, yeah, most probably at the factory they tested this fan or whatever it's called, some heater, it worked. Then the trash bin, it also works, like you can put stuff into trash bin, unit tests are passing, oh good. But then when they tried to put both together into the same environment expected to be used for using this stuff, they got a problem. So integration testing commonly refers to a broader test compared to unit testing, and here I'm referring to Martin Fowler, because, well, I'm nobody, he's the man who's talking about testing, so let's rather listen to him. And he says that it's a set of broad tests, which means that we are not just testing, line of code, we're testing something bigger. But the thing is, it doesn't mean that we have to test everything in our system, actually. We don't have to start, let's say, Kubernetes cluster and deploy every service we have and then test it all together. Because we can start a subset of our services, or in fact, our service, and this service dependencies, direct dependencies like databases and stuff, this service owns. And then we test this service and we call it integration testing. Another definition that I really like comes from Spotify, and they were talking about their testing strategies. And in case of Spotify, they also use test containers, by the way, but they created a definition of integrated test versus integration test. And what's the difference? Because it sounds very similar. Some integration is being tested. But the thing is, instead of doing a classical pyramid where you have system tests, just a little bit of system tests, then integration tests, and then a lot of unit tests, nowadays we can also have a lot of integration tests, and they help to test our systems much better, because today the systems we write, they transform one JSON into another JSON, from one database to some other I/O source. And let's be honest. Unit testing how we transform JSON and assuming that we received the exact same JSON as database provided is pointless. If we attempt to provide mocks for our tests, let's say we assume that Elasticsearch expects this JSON and returns that JSON. Well, it kind of works, but then this is an assumption. You never know how Elasticsearch will behave. And even more, you never know what will happen when you upgrade your Elasticsearch. And we had this case, for instance, my previous company. We were upgrading Elasticsearch from 2.4, I think, or something, to 5.0. And the JSON structure was the same, but the difference were huge. Like, we had to deal with a lot of different behavior changes. And if we would assume that if we send this JSON, we get this in response, that would be incorrect. And I also like the definition of not unit testing, but implementation detail testing. We are not testing units or anything. We are testing some implementation details, because integration testing is nice, but how would we test some little tricky details of the implementation? So we still need unit testing, but we can cover most of the things with integration testing. So we are here and we'll be talking about this part, and maybe to have a cleaner definition, how to understand the difference, how to spot that you're actually using integrated testing and not integration testing, is when, for example, you start multiple services you created. So if you have a company and you have microservices, and most of us are doing microservices nowadays, then if you start more than one service that your company created, then you have integrated test, and then you have a problem, because changes to one of these components, let's say you start certification service to test your service, KYC service, or any other service, and then there is a bug in notification service, and now you're blocked. Your tests are failing because there is a problem in some other service. And instead of using microservice, where the idea was to isolate different domains, now we have a problem because we have this bottleneck at the delivery stage, and testing is an essential part of the delivery stage. So I hope this this short introduction to the domain helped to understand the difference. And the difference is, it can be small, like we start something. Why does it matter if we start one service or 10? But we will also talk about it a bit later. And I'll give an example what can we do about it. So today we're talking about integration testing. And integration testing helps us to check, to perform the reality check, what will happen in real-world scenario with real databases and other stuff when we are isolated, which means that only one component we own will be started from our system, and other components we will start them because we know that this component is the same component as it is running in production, as the ones that we are running in production, some databases, let's say. And when I say we start databases, I mean real databases, not embedded ones, but the real ones. It's challenging, but we'll be talking what can we do about it and how can we achieve it. When we do integration testing, by the way, it's not a black box testing, it's not a white box testing. Let's call it a gray box testing, which means that we know some details of the implementation. We can even assert some internal structures, or maybe we can call some internal methods, something we cannot afford in production environment, let's say, but we cannot affect the internal state of our service. So gray box testing. And maybe to understand the difference of these three stages, because we have three of them: unit, integration, and system testing, I would like to give you an analogy. I have a background from working with different microchips, electronics, and stuff like this. So I would like to use it as my example. And when you design a microchip, let's say, first you design it in some special program. Now we have programs so that we can design microchips in programs. Then you run some simulations, you test it, and it's very fast because you can just click button and you get the result. Oh, good. So we know that our microchip is supposed to work because when this pin receives status 1 or state 1, then this pin will output 0. Very simple. Let's say we design an inverter. Oh, good. Now we order, let's say, 10 microchips so that we can put it on breadboard and test how it will behave when we'll actually run it in some physical environment. So we are not putting it on our motherboard yet. We just order a chip, and then we connect some source of power and maybe some other things just to verify that this microchip behaves the same as in simulation. And sometimes you get some unexpected results. For instance, you didn't take into consideration that in real world, when, for instance, you press a button, it will not be like 0 to 1. It will be 0 to 0 0.1 to 0 0.9 to 1.1. Boom. And you did not expect it, but there is actually a jitter when you press a button. And in physical environment, it's real. You did not expect it in your unit tests. And now we order or we solder everything onto one motherboard with other components, other microchips created by your colleagues. And we also have problems because now we see that motherboard was designed to receive 9 volts of power. And it's good. Our microchips are designed to consume 9 volts of power. But then apparently you realize that when you put 10 microchips on the same board, they consume so much energy that some of the chips are underpowered and the electricity is not reaching to them, or maybe there are some interference or something. But it takes ages to order this motherboard and to solder everything. So compared to 5 minutes in the simulation, now we have something like 2 weeks to order it so that she arrives from the factory. And of course, production. It doesn't mean that if you run every stage and we check everything, then in production everything will be okay. And some of you may remember the story of Samsung Galaxy Note 7, where the phone started exploding, and it's currently banned from many airlines because you cannot take this phone on board because it may explode, and they don't want things that explode in their aircraft. And I'm pretty sure at Samsung they have a lot of tests. They have a lot of different scenarios. They were using these phones at early stages and everything was okay. But then eventually when they shipped the product, stuff happened. So don't think that if you run testing at every stage, then your product will be perfect. But at least you can save yourself from many outcomes in production, and you can prevent many issues in production by doing better testing at your development stages. Summary of integration testing. We, of course, benefit from starting real databases, and when we start real databases, but we isolate our service, we control and we can follow what happens when we do. When we perform the testing without being afraid of one component affecting another component. We can spot the issues at some development stages, sometimes even at your machine, even before pushing to Git, for example, if we have proper integration testing tooling. Which is great because imagine updating or checking that the application works with the next version of the database where they changed everything before even deploying to some development environment. I think this is nice, and this is what we should all have as a target for development. Being able to develop next to our production-like environment without having to request it from our ops team. Unfortunately, or maybe the downside would be that if you have to start real databases, you have to start real databases. It takes time, obviously, and sometimes the time can be significant. Sometimes, I say. It also should be cross-platform, which means that your tests on your machine should behave exactly like the tests on CI or on your colleague's machine, which is Windows, and he's already struggling, right? He's running Windows, and now he has to run some tests too, and now if tests are failing, this is not good. And it's, of course, slower than unit testing because we start some real things. That's the expectation, but still, it's a downside. And the integration testing as paradigm was transformed over the time, and when we started stage 0, it's not the first step of integration testing, but where we started was mocking. We were mocking everything, we were mocking the database, mocking external services, and we were saying then, if we do this, then that. That's our assumption. And people make errors. That's how we make bugs. and we test to prevent bugs. So who will be testing your tests? Nobody. And who will be testing your assumptions? Nobody. Or at least some code review. Code review may help, but it means that there will be bugs in your tests too. So less assumptions you make in your test is always better. So we started with mocking, and mocking didn't really work. So we started using local databases. Because if we use them for development, why don't we use them for testing? We already have an instance of Redis running on my machine, let's say, and then I can use it for running tests too. And it's already great, but the problem is, how do you do the same on CI? You have to go to your sysadmin and say, hey, could you please start a database for me on Jenkins node ABC, port this, and blah, blah, blah. And it doesn't really scale. You have a lot of blockers. You have to request them. And also raise your hand if you ever had to read like 100 million pages of installation guidelines when you join a company. I did, and some did too, because you join a company and then every company will decide how they start their testing environment. Some will say that, yeah, just run this. Some will say run that. Some will say good luck. So, yeah. And these guides are always outdated, right? They never up to date. The only up-to-date guide is an empty readme.md file. It's always up to date. It says we have no documentation, and it's the only constant documentation you can only have. This is why Vagrant became so popular, especially for testing, because now you can describe your environment in a Vagrant file in Ruby for some reason, but okay, we'll get better options later. You describe your environment. You say, I want to start this database and that database and maybe this thing, and it's much better because now instead of requesting and instead of having a lot of custom things, we just say do Vagrant up and everything will be working for you. But the problem is that Vagrant is managing virtual machines, and virtual machines are slow. Let's say to start Redis instance, it takes 200 milliseconds or something. To start Redis in virtual machine, it takes 10 seconds. Because we need to start not only Redis, but also some dependencies like operation system, POSIX compatible, so that it can do some system calls and so on and so forth. And the overhead of starting a virtual machine, how much memory it requires, how much CPU it requires, is much higher compared to just the process. And people started thinking like, okay, we have processes. Why do we start a full-blown virtual machine just for the process? If we can isolate processes and start them in isolation on the same virtual machine, for example, or on the same host. And this is where Docker became a thing. And what is Docker? Well, Docker is a great abstraction layer because with Docker you can say, now instead of thinking of different components, I think about containers. So everything is a container, and as long as it runs inside the container, as long as it supports Linux, I can run it too. And some people say that Docker created containers. It did not. Docker did not create containers. Containers existed for many years, for decades actually. Zones, isolates, LXC containers, and so on and so forth. But what Docker did, Docker created a very powerful ecosystem and a great tooling around this ecosystem. Because building a container before Docker was painful. Docker brought us Docker files so that we can describe it in simple text, basically how we want to build our container. Then starting a container was painful. You had to start 5 or 10 different processes. Now it's as simple as Docker run. And sharing your containers was also not an easy task because there was no common definition of how you share your containers, especially for different systems. Docker Hub made it possible. You push it the same way you push it to GitHub, and then others can pull it. How cool is that? And Docker is a very CI-friendly system because now we change our requirements from, hey, could you please install this on that, to make sure that we have Docker on every CI machine. The rest I will be taking care of myself. DevOps was a win, right? And this is our protocol between us and our infrastructure engineer. And it's of course cross-platform. It doesn't mean that you'll be using, like let's say if you use Mac, it doesn't mean that you start containers in your operation system. There's still Linux VM running under the hood. But it's so transparent to you. You use the same tooling and you get the same result on Mac, on Windows, on Linux, and even if you run your build inside containers already, you also get the same experience, or at least you should. So Docker was a thing, and Docker was powerful. But Docker alone was not enough to use it for testing. Because before we had Vagrant, and in Vagrant we could create a file and describe everything. Now we have Docker, and Docker is Docker run, Docker stop, Docker blah blah blah, Docker, Docker, Docker. Sounds like bash scripts. And we downgraded to bash scripts we were using before with some local databases, which is not cool. We were desperately in need for something to describe our testing environment, and this is where Fig made a difference. And Fig is the name for Docker Compose before it became Docker Compose, because apparently everyone loves longer names and longer CLI commands. So Docker Compose was also a game changer, because now with Docker Compose, you can write the YAML, and everyone loves YAML, right? So you can write YAML. So it was first cloud native tool of year 2000 and forward, because we were able to use YAML. But also, not just YAML, we can also describe something with YAML, perfect. And with this YAML, we can say, I want to run this container and that container and that container. And then with single command, Docker Compose up, we can start them, and then with Docker Compose down, we can destroy them. And then this file can also be committed next to your project, so that you no longer have to maintain this set of bash files or something, and you always know how to stop everything you started. It's very helpful. But, and there is always but, first of all, it's declarative, which is nice, but I want to ask you, does anyone use Kafka? Any Kafka users here? Some, okay. Have you tried to start Kafka with Docker Compose? If you search for something like Docker Compose Kafka, you'll find enough solutions out there, but all of them will be using static ports. Why so? Because in Kafka, the way Kafka works is that when you connect to Kafka on localhost 1992, it says, no, please reconnect to me or some other host, to the host Kafka knows. That's how Kafka protocol is defined for historic reasons. So if you use random port, Kafka will not know about this port, and it will say, hey, you should not be connecting to me over 192 something 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 port 32127. But you know what? Connect to me on localhost 1992. And this is not cool. But also with declarative approach to describing your containers, you cannot do anything with it. There is literally no way to run Kafka on random port without knowing the port upfront. And before you start your Docker Compose file, there are no ports because no containers are started. So we have a problem here. Another thing is, what if I only want one container for some of the tests? So I don't want to start all 10 databases for other tests. I want to start just Postgres or Redis or whatever, because I'm testing a subset of my functionality, and I want to focus on this subset. And what about IDE integration? There are some solutions, but generally speaking, most of them are either for your build system, like Palantir, like Maven Docker Compose something something, or there is also Palantir Docker Rule for JUnit, which is a great solution, but I wanted to warn you that Palantir folks have decided that Testcontainers works better for them, and they no longer maintain Palantir Docker Rule. You can even find a public issue about it. So my personal preference is when I clone a project, I want clone and run. I don't want to read README. I don't want to run any additional command. I just want to clone this project and run the tests of this project. That's the very first thing I do. And if the tests are failing, then there is a problem with the project, not with me. That's what I think. But also, I think that's a good mindset to keep your projects clone and runnable. It will help your colleagues, and especially the new ones who just join your company. So with Docker Compose, we don't have anything like IDE, a proper IDE integration. So that was Docker Compose. But how Docker Compose works? It uses the Docker API, because apparently Docker is just a REST service. You can talk to Docker over REST protocol, and that's it. Why would we use something like Docker Compose if we can call REST endpoints ourselves from our tests? That was the question that Richard Norris, the creator of Testcontainers, asked himself. And we'll be talking about using Docker over API and libraries that help to use Docker over API. But before we continue with just Docker over API, I would also like to talk about some challenges. And the first challenge is how you discover and how you connect to your Docker environment. Yes, it is cross-platform. Yes, it is unified experience. But there are around 20 to 30 ways of running Docker. You run it on Linux, you run it as part of your operation system, and you have socket to access. You run Docker machine, you run it in virtual machine, you use TCP to access Docker. Then you run Docker for Mac or Docker for Windows. They run it inside a virtual machine, but you also have some sockets to connect to. And there are many different ways. And sometimes you cannot just use the defaults, because the defaults depend on your system from time to time. Another thing is we got used to localhost. We think that if we start something on our machine, it will be localhost. With Docker, this is not always true. You run it with Docker machine, it will be 192, 168, something, something. You run it inside a container on your Jenkins, for instance, GitLab or some other CI service, and then it will not be localhost again. So localhost is really not a good thing to hard code with Docker. But what host? We don't know. Like, can we put something else like blah blah host? Not really. We need to find this host. We need to find where containers are actually exposed and running. So localhost, keep in mind, it will work on your machine, but it may not work in some other scenarios, and that's the worst, when something is working on your machine but not on other machine. And not hard coding localhost is a good it's part of etiquette of using Docker. So what can we do about it? We had a lot of challenges, and I'm talking about integration testing with Docker. But so far I was telling you like the issues with Docker, so it's not really convincing, right? And this is why Testcontainers was created. And now I finally will be talking about the library. And what is Testcontainers? Testcontainers is library that was created in 2015 by Richard Norris, who's currently working at Skyscanner. That's an open source library, because some people were asking me, oh, it's so, after the talk, oh, it's so cool, but how much does it cost? I'm like, what? Like, how much does it cost? It's so cool, like it must cost a lot. I was like, no, it's just open source library, go and use it. So it's an open source library, don't worry, there is no commercial offering, nothing like that. And to describe it with one simple statement, it wraps Docker Java library, client library for Java for accessing Docker. But it does so many other things that I'll be talking about, that saying that it only wraps Docker Java library is a bit even disrespectful to Testcontainers, and you'll see why. And it does Docker environment discovery for you. You don't need to configure anything, clone and run, remember? And it will perform the cleanup at JVM shutdown, which is another important thing, and then I'll show you how does it work. And this is how it looks like when you use test containers from Java. By the way, when I say Java, it doesn't mean that test containers can only be used with Java. There is also test containers.js, test containers.net, test containers Golang, test containers Rust from some Bitcoin, blockchain, yeah, from some blockchain folks. So all the hype in one project, right? Docker, blockchain, so on first. So here I'm using Java. And in Java, we got used to objects. We create them and we use them. And test containers is as simple as that. We create the object, we use it. Then, as you can see, we have some specialized containers like PostgreSQL container, because some containers are not easy to run, but we also have an option to run any Docker image you have by using generic container. So if you did not find a module for your database, it doesn't mean that you cannot use it with test containers. You just have to wrap it yourself, and PostgreSQL container extends from generic container. It's just some pre-configuration for you, as well as others. So don't be afraid of using generic container. It's also a very powerful tool. Speaking of the use and the users, because so far it was like, yeah, sounds cool, but I'm not sure I should be using it. I can assure you that there are some very good users of this library, including Spring projects, but also Apache, eBay Marketing, and many other companies. This company, by the way, Zero to Round, does not exist anymore. But I used to work there, and that's how I started with test containers. And I still think that it should be here because the company should exist at least somewhere. But they got acquired. Anyways, another indicator of success of this library is number of stars. And we are not that project. And first of all, we are Java project, okay? When you hear 3,000 stars, for Java it's a lot. For Node.js, it's something you get 1 hour after you publish it on npmjs.org. I know it, okay? But for Java, that's something. And we were growing pretty fast because our users love us. And we never did this thing, we know when someone at conference telling you about some technology and says, after the talk, you can also go and start this project because the developers of this project will really appreciate if you do it, and it's a good thing to do overall. No, we are not doing that, right? It's your decision. It's your decision to go and start github.com/testcontainers/testcontainers.java, and it's your decision, so I'm not going to force it. So, let's go, or let's continue with the use cases. And the most popular use case for test containers would be testing of your services. Not the only one, but the most popular one. And I will be talking about a REST service. I will be using Java and Spring Boot. Yes, I'm saying Spring, but it doesn't mean that you cannot use test containers with any other Java technology. You can. There is literally zero dependency on Spring. It's the other way around, actually. So I'll be using Spring for this demo, but if you use Quarkus, Micronaut, Java EE, or whatever technology you love, then you can as well use it with test containers. Don't worry. We'll be using Redis, Kafka, Postgres, and all of it will be starting during a talk, which is kind of nice, right? Usually takes a couple of weeks to start it properly. And we'll be calling some other microservices. Also, please keep in mind that I'll be using standard testing infrastructure from my framework, in this case, Spring. In your frameworks, you also find similar structures, so don't worry if something you see you will not understand because you don't have it in your framework. You have something similar. Just look for it, and most probably you'll find it. And we'll have some external dependencies, and I'll be using mock server for it. And mock server is a great project, nothing to do about test containers, just another great project. Some prefer to use wiremock, I prefer to use mock server, and I'll show you how to start mock server in container. Demo time. As I said, I have Spring Boot application. If you don't know what Spring Boot is, or what Spring is, or what Java is, or whatever you're doing here, but anyways, I will be using Spring. It's the most popular framework, so most of you should know it. And if I export my application, I will see that I have this API package, I have ratings controller, so I'll be rating some things. And it looks to me that I'll be recording ratings as post endpoint, and I'll be getting ratings as get endpoint. And get returns a map, which means that most probably you'll get a distribution of ratings. Then we also see that I use REST template here, and I go to some other service for the talks, which is kind of nice, right? So microservice architecture. The worst way of doing microservice architecture, by the way, but anyways, I'm using microservice architecture here, and I check that this endpoint returns and doesn't fail, because if it returns not found, I will also return not found, because I will not let them vote talks that do not exist. And then I'll be using Kafka, because I'm a hipster. Event sourcing, CQRS, all the buzzwords. And I return accepted instead of OK, because accepted is the new OK, right? We no longer say that we processed it, we say that we accepted it, and then eventually we will process, but we can also, without leaving the client hanging, can say that, okay, I accepted it, and then go figure. So, apparently, I also have some ratings repository here, so I'm not writing directly to the ratings repository, but I will be reading from it. And if I go to ratings repository, find O, I will see that I'm using Redis template, another template, but it shows me that I'm using Redis. So now I go to my test sources, and I already have some tests, because I've been using some testing with my local database, but now I want to integrate test containers. And if I run one of the tests, my favorite one, and yours should also be, an empty test. What? Really, an empty test? That's the best way of testing your testing setup. Because if you run the tests and then they fail, you should always have a clear answer. Did you mess up the config for the test, or it's actually a business logic that fails? So, the best kind of test, an empty one. I run it and I see some exception. Something, syntax error, SQL database, what? Let me check. Okay, there's some deprecated class. It is deprecated, but without it, everything will break. Okay, nice. So I have some legacy code here too, but it means that I'm running some SQL database too, or at least I need it for my test. And I see that there is also some schema.sql file here. And something is failing. And if I take a look again at the output, it will be something like GDBC, SQL syntax error exception, org h2, GDBC. Apparently, my framework, if I'm not providing any database for testing, will be using h2 database, which is a great database for embedded testing. But apparently, it doesn't like the syntax I'm using. But I'm puzzled because it's the same syntax I'm using in production with my Postgres. I just exported it from my production system, and I was trying to run this test, and they're failing. And if you know Postgres, then you'll notice that I'm using a proprietary syntax for Postgres. On conflict, do nothing. And it's indeed something H2 does not support, at least in the default mode. But also, if I use more features, H2 will fail again. So instead of trying to fight with H2, I will add Postgres. And I will be using containers for running Postgres. But remember, remember this slide with like new Postgres container, new something. We don't need it for Postgres and for SQL databases. Because test containers, the whole idea is to make it simple to test. And we have this, my favorite feature of test containers, support for Spring data, sorry, not Spring, but just GDBC URLs, which means that I can use spring.data source URL, and then it will be something like gdbc etc postgres SQL 10-alpine, and I don't care about host import, and we are devternity, so I'll just use devternity here. And there's one thing that you still have to set. Next release of Spring Framework will not require it. And if you use just JDBC technology, it's also not necessarily to set it, but currently you have to use it, is to set Spring data source driver class name, and then equals to org test containers, JDBC container database driver. I know that some speakers, they use some predefined presets so that they are not typing, but I want to show is that like without copying and pasting stuff, you can actually start a lot of things. So let's just do it all together. So what I did, I just set two properties. And actually, I didn't use any code, just some properties. I could also put it to application-test.properties. But now, if I run the test again, and I hope there wasn't any typo here, but I don't think so. Cool. So I'm running the tests, and now they're passing. What just happened? In test containers, we register a special hook or special driver, magical driver for JDBC. And if you know JDBC, that you know that there are different drivers. But you can also register your own driver, and that's what we do. Then we start a container when you request a connection, and we proxy to the original driver. So we're not intercepting anything, we just call the original driver with host and port and username and password and so on and so forth we just created. Which is kind of cool because you don't need to change a lot of things in your test base to start using test containers for SQL databases. Very nice, and it works with any JDBC technology. So, to start with test containers, especially if you only use some SQL database, it's as simple as changing one or two properties in your test configuration. But now, we need to add more things. Remember I said we have Kafka, we have Redis, and other things. And there is no such thing as JDBC URL support for Kafka because it doesn't use JDBC. So we need to configure our things, our tests. And to configure it, I'll be using another feature of my test framework, context configuration, initializers, abstract integration test dot initializer dot class. This is again a feature of Spring Framework, but once again, in your framework you'll find the same. And this initializer will be application context initializer, configurable application context. And that's a nice thing because now when we initialize the context for testing, we can intercept it and add more properties so that we don't have to set them globally. So now I will define my containers. So first I will need a static Kafka container. And as I said, we have Kafka container with random ports, by the way. Now I need another container for Redis, but there is no container for Redis, so I'll just define it like this. New generic container, Redis 3-alpine. And here I'm using Alpine image because it's super lean and small and just less stuff to download from the internet. We already downloaded half of Maven, so why would we download another half of the internet? And now we also need our mock server container because I say that we run tests with external service for talks, but I don't want to start this external service. I want to mock it. This is why I will start mock server container too. Nice. Now, what else can we do? We can start them, Kafka.start, Redis.start, and so on and so forth, but then we'll be starting them sequentially. But as I said, it's a framework. It's the code you write. So it's up to you how to start things. And with Docker Compose, people ask, how do I start them in parallel? How do I start one after another? With test containers, well, it's up to you, the way you code it. So instead, I'll be starting everything in parallel. And I'll be using a tool from test containers called Startables. Deep start, stream of Kafka, Redis, and mock server. And then I join on the result because it's completion stage. Now I have containers started, and I'll be using last feature of my test framework to set something. It will be test property values. And now I need to set Spring Redis host to redis.getContainerIP address, not localhost, but getContainerIP address. Remember I told you, no localhost, please. Now Spring Redis port equals, and what port should I be using here? 6379? Nope, it's random. But what port? For that, you have special get mapped port helper, and just by using get mapped port, it will return you which port it's using. Now we need to set Spring Kafka Bootstrap servers, but I don't know which port, or like, how do I get Bootstrap servers for Kafka? It's something Kafka specific. This is why we also have these canned containers for different things. And in case of Kafka, there is a helpful method get bootstrap servers, right? So we just call get bootstrap servers, and that's it. If you know Kafka, you know that you need bootstrap server, and Kafka container will give it to you. And last thing, I need to set the endpoint for the talks service. And in my case, it will be just mock server get endpoint. And I apply this customization to my context. Now, if I run the test again, where I also check that it's healthy, my service is healthy, really? Okay. This is why we should not be using magical constants. This is why we have get first map port. Yay. It wasn't planned, but you know, if you want to avoid constants, if you only have one port, you can also use get first map port. And another thing I need to do, I need to create mock server client for another test. So for this one, I'll just create new mock server client. And then we'll say initializer, mock server container, get container IP address, initializer, mock server, get server port. And reset it, just in case. I also have a test, because so far, and you see, it's green, but so far we only check that it starts and house is healthy. Cool. But we need to test our business logic, and this is how we do it here. So we have this ratings controller test, and if we run this ratings controller test, I'll run it in background, but what we have here, first of all, we say, when our application requests /talk ID, then we respond with empty object because the contract is not 404, right? And then when someone submits a rating, status code accepted, eventually we will see it, and I did something wrong, obviously. URI is not absolute. Okay, sorry. There was a typo. Oh, what did I do incorrectly? Services. Yes. So you see, we had we just had green tests that our tests start, but our business logic doesn't work. So, anyways, now we run it again, and it works. Should. And then I'm using availability here because I said we eventually consistent. So eventually we'll see 5 is 1. Then we send more requests and we'll eventually see them. And now remember I just restarted. Every time I restart, I start new container. New Kafka, new Redis, new Postgres, new mock server. How cool is that? And also, when we request unknown talk, then we will see that, okay, for CDI is a great parts, this one is unknown to me, so it will return 404. So it all works. Cool, right? But another thing to check, we're starting something and we run it again, we have some containers. So they created, they are up, and as you have seen, after the test, there are no containers running. And that's a very powerful feature of test containers because it's not just some shutdown hook, it's also a sidecar called Ryuk that is running and destroys the containers if your tests or if your GVM have failed for some reason, have exited with Q9 or something. So again, our tests are green. I already started like 20 or something different data or the instances of databases during this 20 minutes demo. And in my previous companies, sometimes it was taking like 2 weeks or something to start one instance because our sysadmin was always busy, of course. Okay, so takeaways. Testcontainers is an open source library. It works on Linux, Mac, and Windows the same way. So your colleagues on Windows will be cloning and running as long as they have Docker for Windows installed. It works on CIs, and it provides a great balance between flexibility, usability, speed, and features. And when I say speed, please do check latest versions of test containers because currently we are working on reusable containers feature, and it's currently available in preview, where you can keep the containers running on your machine when you develop, so that you can quickly restart tests without having to wait for them to start once again, because you're not changing the configuration of your database. And if you do, then there will be hashing that will eventually stop the previous instance and will start a new one, so we don't have to worry, hey, I changed something, I need to stop containers or something. I think we don't have time for questions unless we do, but if we do, we have to, no, we don't have time for questions. Sorry for that, but there is a Slack channel, and you can also ask questions in Slack channel, or you can find me here. I will also be staying at least until the party, I think. So just find me and ask your questions, and also consider contacting over Twitter, GitHub, or whatever. So yeah, thank you.